Okay, I'm going to go ahead and get us started this morning with some housekeeping. First of all, welcome to today's forest session, our day 4 of our soil moisture workshop. My name is Stephanie Conley. I'm a non-research forest soil scientist with the Northern Research Station for the U.S. Forest Service. And thank you for coming to this very special day and where we're going to highlight forest soils. Some logistics for today. So today is set up to be more than you can handle. You're going to feel like you're drinking from a hose and you're not going to get everything you want. Instead, you're just going to get teasers because we're going to talk about the end of the day, what we're going to do to further all of the things where you like, I wanted to know more, or that wasn't enough, or we should have had more time to talk about that. So we're going to jam it all in one day and talk about the end of the day, how we can do more in the future together. So with that, I'm going to introduce our first keynote speaker, Dr. Cynthia West, my boss, who I adore and fabulous mentor. She's been with the Forest Service for almost 3 decades, or the USDA for almost 3 decades. And she's worked across private industry, academia, and federal government in a variety of jobs. Her sole purpose is to ensure sustainability of our natural resources. In February of 21, she became the director of both the Northern Research Station and the Forest Products Lab of our agency. But prior to that, Cindy started a journey on soil moisture and all things soils, and she will tell you a little bit about that in her talk. And with that, Cindy.
Thanks, Stephanie. I guess I get to kick off this session. And what I want to do is I want you to get the sense of urgency and why foray into soil moisture monitoring in forested areas is so very important to all of us. Now, this journey, as Stephanie said, started about a decade ago when I became the representative for the Forest Service on the National Drought Resilience Partnership. And I began to stalk my good friend over here from ARS, Mike Koch, from Soil Moisture to Soil Moisture meeting, listening to this great plan to increase soil moisture monitoring across agricultural lands. And as I sat there and listened, coming from a background of forest ecology, management, economics, I understood the value of forested watersheds and the fact that, as I reminded all of my ag folks and colleagues and new friends, water runs downhill. So pay attention to the mid and upper watershed. And since that time, when we were thinking about forest health, drought-induced stress, which brought in insects, disease, pathogens, looking at rangeland productivity, and needing to monitor soil moisture to optimize success in replanting forests, that was that time a decade ago. But let me share with you a little bit. Okay, I know there's a trick to advance this. Oh, do I have the, no. Okay, right. There we go. Oh, okay. Sorry, that's right. Okay. Forests across the U.S. No, recently, this last 2 years, the Forest Service and USDA announced this plan to address wildfire risk across the Western U.S. And in the West, we see a large number of public lands. 48% of the Western forested lands are publicly owned. So this is why the federal government and federal agencies have a real stake in this. And these lands surround communities, watersheds, and are above all of the productive agricultural lands out west, particularly in California. Huge amount of income and GDPs generated for the states from across a number of sectors and uses of these forested lands. In the West, 33% of the water comes from public lands that are forested. Over 60 million people across the nation depend on these forested landscapes for drinking water. And over the last decade, we have seen an increase in disturbance caused by climate change, whether this in the form of massive insect outbreaks and dying trees from drought stress, from big storms. I was just monitoring the hurricane off the Pacific coast where the sea temperatures are quite a bit higher this year than they have been on the average, as the sea temperatures are in the east. And as these big changes in atmospheric conditions causes the higher potential for wildfire, high winds, low relative humidities, and long periods of drought. And then we also see big rain events. So this last year, the administration released a report and a concern around the financial risk that this decades-long amount of disturbance has taken in the United States, and suggested that we needed to get ahead of this. We saw some of this in the legislation that was passed in the infrastructure bills, the bilateral infrastructure legislation, as well as the IRA, Inflation Reduction Act. So let's get serious about this, because the trends we see into the future are pretty significant. Increasing temperatures. Since 2000, the average temperature in the US is above 1.35 degrees Fahrenheit above the prior whole 100 years in the previous century. And it's increasing, as we can see every morning on the news reports. And as a result of dry, hot temperatures across forested areas, increasing wildfires. And not only numbers of wildfires, but more importantly, we're seeing larger, more complex fires breaking out. Let me give you a little history. Let's start with the Biscuit Fire, 2001. This is in the Siskiyou, Southern Oregon, Northern California. It was one of those events that woke people up. Conditions were ripe. It was a large fire, the largest that it had occurred in Oregon. Okay, well, we burned that out. We're good, right? Mixed severity fire across a large area of the Siskiyous, volcanic soils, we're good. Well, in 2018, it burned again. And this year it has burned again on the same fire scars. Now, folks who are in this audience who are understand soils, understand what this means to soils and the future of these forested landscapes to be able to recover. After the Biscuit Fire, we have to have a long-term site productivity study there that had been in place. And a scientist, Bernard Borman, went down and looked at this. And it happened to burn in a perfect split design. High severity for half the plots, low severity for the other. And what we found, because we had measurements before the fire, over 60% of the soil is lost, both organic and mineral. All right, let's segue to last year. And while soil moisture becomes more important in forested areas related to fire, Calf Canyon Hermit's Peak Fire. Who has not heard of this fire in New Mexico? All right, you know, April 6th, we had an escape prescribed fire in one area. Hermit's Peak Fire, April 19th, a pile burn that was burned in January using the protocols that we have used for a very long time, successfully, I might add, was started in January. This pile was burned. It was busted apart as the protocol called for it and had several feet of snow up on it over the winter. And then April 19th, this pile burn started a fire, the Calf Canyon Fire. Why, you ask? Why? Well, when we pile burn on top of very dry soils that have been through drought, that have organic matter in it, we can create the perfect conditions for smoldering down into the soil over a very long time. And as the wood smolders and also then dries out and catches on fire, other organic material under the soil that can spread underground. And that's exactly what happened. How could we have been prepared for something like changed conditions, is what I call it. Changed conditions, which says, hey, we've got to change our protocols. We have some risk here. And that was one of the findings in the 90-day stand down when we looked at prescribed fire and what we need to pay attention to and what was a why are we seeing some of these fires? 904,000 acres burned, 900 structures lost. Okay, let's tell the California story, because I think this brings it all in and brings it home. As we all know, we've watched the 4 years of drought progression over time in California, resulting in massive forest losses, beetles, dieback. I talked to one industrial forest manager who said he'd never, working there for over 35 years, had never seen anything like it. The trees were so dry, they couldn't even pitch out bark beetles. No pitch was produced. So a tree, on average, most species, 50% weight in water. So these trees had lost so much water, they were incredibly dry and ready to burn. Now, when they burn, they put in danger our watersheds and public water, as well as water supplies for agriculture. And with 129 plus million dead trees that are highly flammable, well, we know what happens after that with fire. Let's look at the California fires. These are the largest, most significant impacting fires. Largest, August the 2nd, 2020, the August Complex, Mendocino County, over 1 million acres. July 2021, Dixie Fire, almost 1 million acres. July 2018, Mendocino Complex, almost 500,000 acres. And then August 2020, SCU Lightning Complex, Stanislaus County, almost 400,000 acres. Do you see the pattern and what has followed behind the dieback of these forests and trees? And then sadly, we know what happened in September of 2018, the Camp Fire, wherein 85 souls were lost. All right, what happens when things don't dry out? When we get big storms events, high snowpack, and then rain on snow events, we see tremendous flooding. So not only is it important to monitor soil moisture and because we're looking for not enough water, but we need to understand then the condition of soils and moisture in those soils when we get these events of too much water, and where we may be at high risk for landslides and flooding. So this last December, they had massive landslides across the forests in California where we've had fires, massive landslides. So even though we need to go in and remove biomass from these forests, we can't get in. The roads are closed because of these landslides. This atmospheric river that came in and just pounded the West Coast. So I'm going to end where Mark Brusberg started, and that is, why haven't we made more progress? I'm going to suggest, no, I'm going to hypothesize with strong evidence that we need more agencies to work collaboratively to enable more efficient allocation of resources so we can accomplish our shared objectives, and to address more the information gaps in forest soils in a cross-sectorial manner. Ag is great. Food production is extremely important. No, it's important to life, but so are some of these other things. And so when we have multi-sectors and bringing multiple and bigger stakeholder groups together to look at how we can move faster to implement information, to expand our soil moisture network, advance the technology for monitoring soil moisture, and understanding when we see these big deltas, what that means in terms of decision making, so we can reduce not only financial losses, losses of nature's green space, and but also the impacts to communities and people and lives. We have advanced since the first time that I addressed this group, I guess back in 2018, in collaboration. So collaboration with NRCS in looking at our watersheds and our experimental forests. We have 60 plus years of data of looking at soils, moisture, stream flow, of being able to do some sense making about the type of soils and what we're seeing as changes over time in soil moisture. And we have made progress in looking at how do we get ahead of information for fire and fire prevention and improve our models, and including when we see these big deltas as we try to reduce fuels using fire. And I'm happy this year with a lot of collaboration and networking that we're beginning to advance putting soil moisture probes onto our raw stations and remote weather stations that we can put out. And we have some permanent ones and some mobile ones for monitoring fire conditions. And we have advanced in collaboration with states and advancing the mesonets. So I think we've accomplished a lot, and I think we've been building this network of collaboration and understanding of the connection between forested areas and the valleys below, as well as the importance to communities and a whole host of stakeholders they want. So thank you. I'm really looking forward to this today and towards the end of the day to look at where we go next.